Alright, chapter 8.1, determining the optimum area or perimeter. By the end of this class, I should be able to optimize the area and perimeter. So here, you know what that means? Optimize. Make it the best. Optimus Prime. No, you know? You know Optimus Prime? No? Bad movie though. Bad. If you're making a container, you probably want the container to do what? To make sure it holds a lot, right? So the optimum area or optimum what? Volume. However, you probably don't want, what would be the optimum perimeter or surface area? It'll be the what? The least, right? Because you don't want to use a lot of material to build your shape. Do you understand that? So to optimize in this case, area and perimeter, it means to maximize the area. You want the biggest area possible, but the smallest amount of perimeter, fencing, for example. Okay? So here, it asks you a question here, to draw three different rectangles with a perimeter of 24. So tell me, what would be a rectangle with a perimeter of 24?
4.
I'm sorry? What by what? 4 by 6 would make a 24, right? I need a perimeter of 24.
Oh, perimeter in the area.
8 by 3? No, 8 by 3 would match, right?
Oh, 3 that gives you 12.
Right. Yeah?
Perimeter of
8 by 4, okay, here. So 8 by 4 gives you a what? Perimeter of what?
36.
That's 12. They add up to what? 12. 12 times 2 is what? 24. So this 24. What is the area of this? Okay, 32. Okay, good. Now, what else? 2 by what? 2 by 10. So I can have a 2 by 10 one. And that's still the perimeter. So 10 by 2. So the perimeter of this one is what? The perimeter of this one is what? 24. What's the area? 20. That's interesting. What do you notice about the area? They are different, right? You use the same amount of perimeter, but what's inside? The space it takes up inside is a lot smaller with this one than this one. Do you understand that? Okay. Now, what's another one? I think Reina said something. 6 by 6. Okay. That's what we all say all the time. Perimeter is what? 24. And the area is what? 36. Oh! So this one has the what? Biggest area. And the thing that students always say is, you just said what? A rectangle. But you drew a what? A square. But remember, a square, okay, all squares are what? Rectangles. All squares are considered to be rectangles. Specific rectangles where they have all what? All same side. Is that okay? Alright. So, let's answer the next question. Which of the rectangles had the biggest area? Alright, so let's write that down. The answer to this question is, we had the 6 by 6 square. Okay, that's the important part. A square had the best, okay, the best area. So my conclusion in this case would be what? to maximize the area. Oh, to maximize. Given a perimeter we need to create a, what shape do you think we need to create? A square. Okay? Or close to a square as possible. Where is it?
Given, before given.
Maximize the area. There you go. Given a perimeter, we need to create a square. Does that make sense? Okay. Of course, this is if we're trying to make what? Rectangles, because a circle will be better, right? Yeah, if you think about a circle, there are no edges, right? So it does create the biggest area if you make a circle. But we're talking about rectangles. If you have to make a rectangle, the best way to get the most area out of whatever you're making is to make a what? A square. Okay? Alright. Alright, so here we go. Let me finish up the conclusion here. So we gotta try to make a square as possible. So we gotta try to make our rectangle as squarish as possible. I'm gonna call the length S. That's not a 5, that's an S. And then what's gonna be my width then? What am I gonna try to make the width? If I make the length S, what am I going to try to make the width to be? S as well, right? You got to be a square. So, the perimeter formula again is what? 2 what? L plus W. However, when I'm trying to make a square, I know that what? The length is equal to what? The width, which equals to what? S. Is that okay? To make a square, or a square, okay, L equals W equals to S. So I'm just going to replace the letters with S, just to simplify it. So this is what we got. 2 S plus S. What's S plus S? 2 S's, yes? Yeah. And then 2 times 2S gives you 4S. Okay, so this is the perimeter formula for a what? For a square. Which makes sense, right? 4 equal sides. 4 times the side length gives you the perimeter. Okay. So, did you hear what I said? Okay. Area. Yeah, you only can afford 30 meters of fence or something, and then you want your dog to be able to run around, a lot of space to run around. You want to maximize the area. So what kind of shape are you going to make? Are you going to make this little thin strip where you can just run up and down and barely turn around? No, right? Because that's going to be a very small area, okay, compared to the area that your dog can go do his business around, right? So, listen up. You always look at the information that you're what? Given. And that is your what? Your perimeter. Because you're given the perimeter, you always start with the perimeter formula. You understand that? If you're given the perimeter, you better start with the perimeter formula. It makes sense to do that. So the perimeter formula that we want to use is what? 4S. Because what are we trying to create? we're trying to create a square. Does that make sense? So now what do? Instead of P, what do? Yeah, you just plug it in. Guys at the back, pay attention please. Okay? Remember, I told you, very easy. You know, you're given information, all you need to do is plug it in. So 30 is equal to 4s. How do you isolate s? Divide both sides by what? 4. Okay, so s is equal to 7.5. Okay. So I always ask this on the test. It says, what are the dimensions? So basically is, what is the size of the panel that you actually have to build? And you have to draw it. And please try to draw what the shape is supposed to be, which is a what? A square. That's what? 7.5 by 7.5. And I will put maybe 6 here, so just to know that they're the same length, right? Some students are like, here's my panel, 7.5 by 7.5. Really? It doesn't look close to a square. Okay, so make sure you just draw something that resembles somewhat a square, okay? Alright, what's the maximum area then? It's length times what? Width? It's 7.5 times 7.5, and that gives you something. What does that give you? 50 what? 56.25, I think was?
Yeah.
Meters squared. So your dog has 56.25 meters squared to run around. Is that okay? Alright. Okay, now we want to optimize the perimeter. In this case, we want to minimize the amount of perimeter because, if you minimize the amount of perimeter, the less material you have to buy. So what I want to do is draw 3 different rectangles with an area of 36. Okay. Whatever. I guess this is meters squared. Let's just say meters squared. So what would I have to do here? I should have chosen a different number here. But what are some different ones? 4 by what? 9. Yes? So the area is what? 36. What's the perimeter? This times this gives you what? This plus this gives you what? 13 times 2? 26. What else will give you 36? What by what? 3 by 12. So the area is again 36. 12 times 3 is 36. The perimeter, however, is 15 times what? 2, which gives you what? 30. So notice here, the same what? Area, but the perimeter is getting what? Bigger as the numbers are getting, as the difference is bigger, right? Yeah, further apart. So guess what you have to make this time again? A square. So the best will be a square, which is what? 6 by 6. In this case, so the area is still what? 36. However, the perimeter is going to be 24. The perimeter for this one is the least when you make a square again. So let's summarize that. Alright, so let's finish this up. So if we want to minimize the perimeter with a given area, we need to make a square. Or come close to a square as possible, right? Sometimes you may not be able to do a square. For example, you know, you have those like big cement blocks, right? And maybe you don't want to cut them. Then maybe you cannot make possibly a square, but you're trying to come what? Close as possible to a square. Right? Okay. So again, what's the area formula? Length times what? Width. However, again, for a square, the length is equal to what? The width, which equals to what? The S. So you get S times S. And S times S is S squared. Oh, look at that. S squared. Remember, guys, chapter 2, when we drew x squared. X squared was the what? A square. Right? So x squared represents the area of a square, but that's x by x. In this case, the formula is S squared. Thank you. Write this next section down, and this is our last example. Again, same thing. You just look at the information that's given to you, and you can see it's what? 40 meters squared. So that is the what? The area. So then you must start with what formula? The area formula. Now the area formula you're starting with is not length times width. It's a specific length and a width, right? You're trying to make a square. So you need to start with S squared. You plug in what you know. Dominic, what do you do? You plug in what you know, what do you write? 40 equals S squared. And then you get rid of that little 2 by. Isolate S by square rooting. So you square root both sides. So S gives you what? 6.3 or something. So again, can you stop talking, please? You're trying to make a what? A square with a dimension of 6.3 by 6.3. And so, the perimeter, the amount of fencing you have to buy would be, the perimeter would be, what's the formula for it? 4S, because it's a square, so you go 4 times 6.3. I guess I'll write the formula here, 4S. And that gives you, what did it give you? 25.2 meters. So you need to go buy 25.2 meters of fencing to make this panel with the maximum area here.